Hello, hello, it is Mrs. Edwards and we are back. It is time to do math and I love it. Today we get to find some derivatives of exponential functions. So what I've done here is at the top put the formulas for finding the derivative of exponential functions. Ultimately it boils down to the one in the top right hand corner, but this one here on the left is a bit of a shortcut if the exponent is just plain x. So ultimately, the derivative of a number to the x is natural log of the base multiplied by the original. Now, when the exponent is more than plain x, we have that input function, that ugly, and we'll need to chain on the derivative of ugly. So you end up with the natural log of the base times the original times the derivative of the exponent. So let's put that in action. The derivative of 2 to the x power. 2 is my base, x is the exponent, all right? So it's simply going to be the natural log of the base multiplied by the original. So ln of 2 multiplied by 2 to the x. Next one, if I do the derivative of e to the power of x, e is the base number, x is the exponent, so the answer is the natural log of the base times the original. So ln of e multiplied by e to the x. The natural log of e is just an identity. It happens to equal 1. Reminder of a log property, how we get there. Every single logarithm, natural log, has a base of e, and the exponent on that e is to the first power. When your logarithm base matches the base of your power, all of that goes away and you just get the exponent. So the natural log of e is equal to 1. So we have 1 times e to the x, which is just e to the x. Many people have the derivative of e to the x memorized because it's just itself. The derivative of e to the x is e to the x, and you don't give much thought to it. All right, so let's take a look at another one. The derivative of 7 to the power of 3x to the 4th plus 5. This time, our exponent, right, it's more than plain x. So we are going to need to chain on the derivative of that exponent. We're going to have natural log of the base multiplied by the original times the derivative of the exponent. And the derivative of 3x to the 4th plus 5 is 12x to the 3rd. And we cannot simplify that anymore, so that one is done. The derivative of e to the power of 2x plus 3. Okay, so one more time, it is the natural log of the base. So natural log of e multiplied by the original multiplied by the derivative of the exponent. The natural log of e is that identity, that just equals 1. And then the derivative of 2x plus 3 is just 2. We could simplify that one. I'm going to rewrite that as 2e to the power of 2x plus 3. Okay, so I'm going to go back to that statement just really quick. We could have done these two on the left-hand side using the rule in the top right-hand corner here. Because if we do natural log of the base, the original times the derivative of the exponent, let's come back and do that. Natural log of the base, ln of 2, the original, 2 to the power of x, times the derivative of the exponent, the derivative of x is 1. Right, that extra little part in that chain rule, you're just multiplying by the derivative of the exponent, and when that exponent is just x, we'll be multiplying by 1. So often you see these treated as two separate things to know, but ultimately if you know the natural log of the base times the original times the derivative of the exponent, that will find you the derivative of every single exponential function. But that is taken care of the chain rule. Okay, so I'm going to contrast that really quick to the derivative of logarithms that we just learned. I think it's a really good idea that you compare these to help you, frankly, just with memorizing. Look for some similarities and kind of pull that information together. So notice that for the exponential functions, we have base A and ultimately take the natural log of the base A. For logarithms, the base is down here, and we ultimately multiply by the natural log of the base. So a base for exponential functions would be A up here. The base for a logarithm would be here, base B. But in both instances, the derivative, there's the natural log of the base involved. Now, just to help your memory maybe, where are you going to put the natural log of the base? Well, if you're dealing with exponential functions, I think of exponential functions, they skyrocket, right? That's the look of an exponential function. So I think about going up high for exponentials. Well, the natural log of the base will be in the numerator, right? Up high. Now, when it comes to logarithms, they're kind of lazy and they just curve along so slowly. Okay, for logarithms, the ln goes low. So logs, ln goes low, and for exponentials, ln goes high in the numerator. Okay, so one more time, just comparing those. The derivative of a to the x, ln of a is in the numerator. The derivative of log base b of x, the ln of the base is in the denominator. Okay, then after that, this one we just have plain x right now, so let's change that over. If we had the chain rule, the overall rule is 1 over what you're taking the log of multiplied by the natural log of the base, chaining on the derivative of what you're taking the log of. Thinking about input functions, right? Input functions often show up inside of grouping symbols. And when you're dealing with an exponential function like a to the power of x or a to the power of u, whatever is up there in the exponent, that's actually inside of parentheses. It's inside of grouping symbols. And whatever you're taking the log of, right, that's inside of grouping symbols. So we chain on the derivative of what's inside of grouping symbols. So that's true for both of these. We're chaining on u prime, what you're taking the log of or what's up in the exponent. Okay, so take a moment, maybe jot down these formulas and compare them to help you with your memory. But ultimately, the shortcut is if you use these on the far right-hand side, derivative of an exponential function is ln of the base, original times exponent's derivative. That will find the derivative of every single exponential function as long as you know that the chain rule was already taken care of. Same thing here with the logarithm. Every single logarithm that you find the derivative of, it's 1 over the argument, that's what you're taking the log of, 1 over the argument times the natural log of the base number multiplied by the argument's derivative. Again, the argument is just what's in parentheses, what you're taking the log of. All right, so you should be able to find derivatives of exponential functions and logarithms. I feel like I might as well just give you a quick reminder of some exponential rules when you go to simplify answers. This first one, when you have like bases, you add exponents. Okay, this one, when you have like bases and you're dividing, you subtract exponents. When you have a power to a power, multiply, you want to multiply the exponents, and then any number to the 0 power, of course, equals 1. And then if you want to get rid of a negative exponent, and it's all multiplication going on there, you can cross the fraction bar line to change the sign on the exponent. Cross the line to change the sign. So those are some good rules to keep in mind. But ultimately, be sure that you jot down those properties when you do your homework tonight. The derivatives, a lot of them are going to include derivatives of exponential functions, but mixed in there, you're going to have the, power rule, product rule, quotient rule, all those good things. Okay, I hope you guys have a great day and good luck.